and do a very simple, okay, so this is Netbeans, our famous and happy Netbeans. And I'll create a new project, simple Java application, new PDC threading example. Okay, so that is a simple class with public static void main. Right. I'm going to write two functions, right? And those functions, I'm going to put them in a different class, which I'll call work. Public static class. So I'll call this, okay, I'll call it workers. Maybe people would enjoy it, right? Now I'm going to do two methods. One method that prints only odd numbers, and one method that prints what? Even numbers. So very easy to do. Hopefully I've not been doing too much C# and forgotten my Java. Public void print odd. Right. And so what you do is for int I, okay, let me make this, okay, doesn't matter, I'll just let it go. I equals 0, I less than let's say in j equals, I would like it to be easy, I plus, oh. Okay, and I'll do, this one is system dot out dot, oh, not air. But system dot out and system dot air are very interesting from a programming perspective. When you say system dot air, usually printing console, you make sure it comes to screen. So, because an error is something that usually has high priority, so you see it much quicker. So if you are debugging with system.out, you may not see it, because if the program dies, it's gone. But what I've seen with air is at least system.air, it will come out much more forcefully. So when I'm debugging and I want to know, did it actually work? Even though there's air, there's out, if I know something is wrong, I'll use the .eer to make me know that, oh, this is an error message. So it comes up very quickly before the program dies. Okay, system.out.print line. Okay, so this will be printing a bunch of odd numbers. This is print odd, and I'm going to do another one called print evens. Okay, it says it already exists. Alright, so back to this public static void main. I'm going to make an instance of that class. Worker w is equal to new worker. Okay, w dot print even and w dot print odd. Okay, so let's run this. This is my main, so I'm going to run this. And please be good. Okay, so run is coming, and you can see at the bottom there, it printed all the evens followed by all the odds, right? So we're going to make this program a little bit more interesting in that we're going to do some sleeping. So say sleep for maybe 1 second. He wants to be in a try catch because it could fail. Surround with try catch. Right. So sleep means that he'll run and then he'll go to sleep, and then he'll wake up, and then he'll go to sleep, he'll wake up. I'm going to reduce the number of times it prints because 1,000 is a bit much. So I'll make it 10. So it doesn't get too out of hand. And similarly, I'm going to make this one also wake up and sleep for 10. And I'll just run the same program. So what we are doing is, we now have two functions that are supposed to run independently. So it's counting 1, 2, hey wait, he didn't do even. So what do I have to do to make him do evens? I can multiply by 2. Or go up in counts of 2. Okay. Plus equals 2. You can do a lot of crazy things in these semicolons. Okay. And this one, oh, was this the odd one? Okay, if it's even, this is fine. Because you go to 2, 4, and so on. And there's also print odd. This is the print odd one. he can start from 1. And I can even have him print a message. So I can. Oh, is this the odd or even? This is the odd. Is odd an even number? Is 0 an even? Okay, that's another debate. People are more inclined to believe 0 is even than 1, like than 0 being odd. So the yeah. Whilst odd, usually you get a remainder of 1. So 0 divided by. But I have to check what the formal definition is. Some of these you have to be careful. Okay, so even. So I'll print the even this way, so that when it's printed, you know that the even one is talking. And I'll print the odd this way. So, run. Oh, did the odd guy do the wrong? Oh, the even is printing, what he's saying is wrong. Okay. So, this is one of the lessons as you are designing your systems, is a lot of the things will be based on text. So, you have to carefully make sure you test everything. I know people are used to just writing a lot of code and then just hit play and hope that it'll all run. But I don't code that way. You can see I am very, I don't know, is it methodical or something? It has nothing to do with methodism. It's just a way of coding that you are structured. Now, if you write something, test it, make sure that the function works, and then you wash your hands clean. Like, oh, that's working. I don't have to do it anymore. Right? So the odds are printed, the evens are printing, but one prints followed by another. So this part, it's not magic, but everyone should watch very carefully so that you don't get lost. Right? So in order to make something hey, have I forgotten how to spell Runnable? Does anyone remember how to? Well, implement Runnable. Implement all abstract methods. Right. So Runnable is a class that Java has written for you. That means that it has already some methods that you can overwrite, and then it will do the work of a thread. So a thread. So what we'll do to prove that this program can think with two things at once, you run the two functions in parallel, right? And you see that this one ran a bit, and then this one ran a bit, right? So I have this one called Java Worker. Oh, I know we have just 10 minutes, but we can do it. I'll even go a little bit more, because this is important. You have to build it. Okay, so implement Runnable has, whenever you say something should implement Runnable, what it would get is, he has to override this method called run. Right. So I'm going to do something interesting with this thread. Right. I'm going to create a constructor. So public worker boolean do odds. Right. So this is something that people in OS sometimes struggle with. That is, they make a lot of threads and they're wondering, how do they all interact? And the point I say is, it's possible for any class at all. So do odds equals false. Right. So this means this is a class that has a definition of do odds. Do odds is just, if do odds is true, he would work with the odds. If do odds is false, he would work as an even function. So depending on what the value of do odds is, he will do either evens or odds. This is a class I've extended. So worker was the original class. Worker had two methods, print odd and what? Print even. Print odd would print odd numbers, print even numbers. But what I want to do is, I'm extending this to make it a thread. So a thread means that I would like it to, at some point, be able to run independently and do whatever he wants to do, like happy, dancing in the rain, like this. Okay, let's extend it. Let's bring this. So what I do is I say implement Runnable. So for doing threads, implement Runnable is very important. Right? So then when you say implement Runnable, he would ask you to override the run method. Right? Because that's an abstract. Okay. Okay. So once I have this one, that means I'm going to say this dot do odds. I hope people know like what this is doing, right? It means I'm taking something from the parameter and assigning it to something within the class. Right? And then in my run, I'm going to say if, okay, you don't have to say this.doAuth anymore because he's the only one who is doAuth here. Then he's going to call, well, I'm mixing it up, this dot print auth else. So this is a very simple program. That means that if doAuth has been set to what? True, he'll do the odd work, and if it's been set to false, he'll do the even work. Right. So let's see this in action. So now that means my current worker is not going to work anymore, right? It has to be changed in behavior, so that everyone is like at least aware of what's happening. Boolean doAuth. I would say I'll write it this way so people don't think that it's because of the variable name, right? So I have doAuth. I create an instance of the class, right? But instead of calling these methods directly, I'm going to call w.run. So what do you think will happen if this is called, if this run is called? Which method will be called? From run, it will go to here. And when it gets here, you check what the value is. Is it this running? If this is doing, it will do it. If not, you do this one, right? So that means that at least we've thought through it. So I'm using Netbeans to show you. So how I jump around is, you can hold the control key, and when you click on the method name, even when I just put the cursor over it, and I hit control, okay, so I either hit control, bring the cursor, it will bring the name. So once my thumb is on control, if I put on something, it tends to at least tell me what it is about. And then if I click, it will take me there. Microsoft Word works the same way. If there's a link, you click, you can open it without having to open your browser separately. Okay, so if we run this, that means that we expect that this would do the odds, right? Odd 1, odd 2, because odd has been set in that class. When he gets there, he knows what to do. Okay, so we can do odds. But now we're going to do at least the exciting thing that most people have not been thinking of as far as problem solving. That is, can I run 2 versions of this? That means this is a worker that does odds, right? And another worker that does, okay, I'll put not here. So he does events. If I say w odds.run and w events.run, in a normal program, this one we can wait because it's not the registry. Sorry. So there's a priority queue, sorry. So I usually call this like, we have to quickly take it. So this one, we'll take it after class. Okay. Okay, so the odd is running first because he was called first. So odd, and then the even one runs. Right. Now, if we want to be fair, that means that now we can say odd and even run at the same time. And so that's what threading, the whole goal is. That means running 2 things at the same time. So in order to accomplish that, what we do is we say thread, T for odds, new thread using odds. Now, this setup, what it actually means is, go and take a runnable. So the runnable is w odds. Take it, instantiate a thread with it. So once I've instantiated a thread, it means that I don't have to say run anymore. Instead, so I'll do 1 for odd and then 1 for even. And that means instead of saying w odds run and w evens run, what I instead say is t odds dot start and t events dot start. Oh, not events. Now let's run this and see what the new behavior will be. So you see now they seem to be running at the same time. Oh, and see they are all, and it could have been, so odd runs a bit, even runs a bit, odd runs a bit, even runs a bit, right? So what this is, at least the core thing you are seeing here is that means that now it should be possible to write a program, just one program, who is thinking and doing multiple things at once. all he has to do is he can say, okay, I'm going to be doing calculation. He calculates a bit, he can sleep. He runs a bit, he can sleep. And then his other methods too can have that sort of strategy. So that means that in one program, you can have multiple things going on. So someone can say, okay, if you want to get much more complex, like on your phone, he checks for notifications, he checks you have SMS. That means that one program can be what? Multitasking. He has one method that does this, one method does that, one method does this. He could even say, I sleep, then I call this method. I sleep, then I call this method. I sleep, then I call this method. Right? And actually, the way that most web servers like Apache works, that's how they actually working. What they do is, they wake up, they listen to the connection, they handle it, they'll sleep a bit. Then they wake up and listen for another connection, they handle it. So the idea is, a lot of them are going through these cycles of, I wake up. The sleep, usually in a thread, is to yield. When you sleep, that means that if there are other threads who are available and someone is ready to go, he will be allowed to run. So that's the strategy I usually use. So even if you sleep for, let me see, well, this is the worker, right? Previously, they were sleeping for 1 millisecond, right? Oh, sorry, 1,000 milliseconds. I can even let them sleep 1 millisecond. I've increased the number, but now they are sleeping less. But anytime someone sleeps, that means that he's going to yield the processor, well, at least the current context, to whoever else is available. So let's run this and see. That means this will be very fast, right? But that means it's a bunch of going. They're all printing all at the same time. And so that means the other thing about threads is it's not predictable, because maybe sometimes you sleep, the system will try and say, oh, let's pick another person. Maybe it doesn't wake up, then it goes to pick somebody else. And sometimes maybe someone is printing. And remember, even during the print, for it to print, that means that the OS or some lower level system is listening for the messages. Because when you say print, it doesn't happen instantly. Someone has to take the output and then bring it to screen. So that means there are other systems within the OS or within the framework. In this case, this is the JVM. That will take it and bubble it to screen. So that means that he also is listening. He listens to this, and actually what you see is, going through this, it's not so clean. It seems like one person is going faster than the other. Let's see. By the time it gets to, okay, you can see, especially at the end, the odds guy seems to have a lot of work to do. Like the evens has finished, and the odds, that means that at some point, the even guy probably was doing more. Here, you can see odd, even. Here as well, right? He did a bunch. Right? So that means that now you can start thinking in terms of programs where it's not like only one. You can what? Multitask. That means this one runs a bit, and then this one runs a bit. Right. Do you guys have another class, or I think someone has software engineering, right? Is software engineering running today? There's no software engineering today. Okay. Okay. So the other thing, so when you are doing threads, when we are doing operating systems, we would actually do things like how do you lock and unlock. We go into it in so much detail. Now the reason why we think of locking and unlocking, so this is a consequence of or the shared memory, right? So anytime you are sharing something, so we talked about pipes, we talked about sockets, but we have not done sockets yet. We skipped it, right? But we've done, at least we saw sockets in terms of, oh, Apache has all these sockets, but we've not actually coded one yet. So the next class we'll actually go through that part as well, right? So if you look at it carefully, that means that whenever a program is running and it has threads, there's the possibility that it would contaminate. Imagine that someone is working on a linked list. The moment someone made like a pointer, then all of a sudden he stops because another person wants to run. And remember that as long as you have two or more threads, they will be scheduled. The same way that because you have more than one program, no program runs forever, just as no thread runs forever. So actually, if you look at the CPU, this is the Process Explorer, you can tell that the programs are running like at different percentages. If you sort, you can see some people are running more than others, it's moving, and that's because for most systems that are running code, he runs this a bit depending on his strategy. He may be doing round robin, as I said, gives everyone a bite. Or it may be based on priority, where he says, you are high priority, you are less. But that means that he's not going to let one program run all the way. In any operating system, you can see Notepad is open, Process Explorer is open, WordPad, Visual Studio. That means that he's multitasking. The OS himself is doing the same thing that Threading was doing. He looks at this one and it runs it. Looks at this one and it runs it. So that means that whatever you do, it's possible that halfway through a task, you will be interrupted. And then that means that you have something like a linked list. You've made a note. You didn't put something there. Then all of a sudden, what? You are taking off because someone else is running. And that person wants to use the linked list. He takes it, gets to the end, reads and says, what's the next pointer? There's nothing there. He crashes. Right. So for a lot of the data structures that are complex, like your trees, hash maps, even some of your own, where maybe you design your own code and you're supposed to make sure, maybe you're calculating someone's GPA. You add in the cost, you calculate the current GPA. You add in the cost, you go to calculate the GPA. It stopped. Someone else is running. And say expelled. But maybe if that cost had been added before that other program ran, it would have been a different case. Right? Or maybe you are doing banking and someone is supposed to transfer money from this account to this account. He takes the money, he didn't even drop it yet. And then he says, I'm going to update that you have more money. Right? Or maybe I'm going to update that you have deducted money. So the deduct money one is a funny one, where maybe there are two threads running. One wants to take 1,000 Ghana. One also wants to take 1,000 Ghana. You have only 1,000. So one sees it and says, approved. I'm going to, before he writes, he stopped. The other one says, I've got the money. Wants to take it. Then before he takes it, he's also stopped. And both of them print, you've got money. So the cashier gives the money out, give the money out. And before he saves your new balance, what's happened? Another person has come. Ideally, it should be that one person between looking at the amount, taking the money, and then updating. It should be atomic. Done databases. Right? Everyone has done database. So I think in database they talk about atomicity. Where atomicity, asset, come on, everyone has done asset. What does asset stand for? Okay. So for databases, look up what it means for asset. It sounds like asset benefits. It's an acronym. Right? But the first one stands for atomicity, meaning that something happens all at once or not at all. So if you're transferring money, if you say maybe transfer money from current account to debit account, you should do that in one transaction. It shouldn't be like, I took the money, but I didn't transfer it yet, and I don't know yet. And so it must be consistent. There has to be a consistency. That is, if I'm moving money from one account to the other, the sum of the two accounts has to be the same at any point in time. Else, when you go to your account and say, how much money do I have? And sometimes you say 1,000, sometimes you say 2,000. It's kind of scary. Right. So it would be nice that the system should know, I should make sure that the data is consistent. If your total amount of money is 2,000 and I'm transferring money from one of your accounts to the other, why should your balance or total amount change? You should make sure that he moves it in one action. Right? That way, the people are doing deductions. So it won't be possible for two people to take all of your money at the same time. For one person, they take 2,000, another person, they take 2,000. That means 4,000 in total has been taken. But it's only because one person didn't stop for the other. Right. The other example I gave, which is a very bad example though, is if you look at most bathrooms now, most bathrooms have a lock. And it's like there's someone in or someone not. Because it's kind of annoying if two people enter the bathroom at the same time and are trying to do action at the same time. So there are certain things in life where human beings know only one person can be in there at the same time. So we design it such that, at least for bathroom doors, you make it like you open, you close, and when it's locked, there's someone in there. Right? So that's the idea of locking. The idea of locking is we should have a way to make sure that only one person is working on some objects at any point in time. Right. Now, the way that usually we accomplish it, so I'll discuss it now. So I mentioned it in the statement, right? And the method we use for that is called synchronized. So I'll do, okay, so I'm going to make a new class. And this is a class, in your design, what you have to do is, when you have multiple threads, sometimes you want them to coordinate, right? Maybe there's a list they are all supposed to work from. So everyone wakes up, the thread will check, how many things do I have to work with? Then he does some work and then he stops. Okay, if the list gets to 100, someone else also checks. He wakes up, is it 100? If it's 100, he's supposed to send a message and do some other work. Then he sleeps. So the idea is, now you have to have some way to make sure that the threads they don't interfere with each other when they are sharing things. So imagine you're trying to use your laptop, someone is typing, you're also typing, same as, right? Or you're trying to print, even printers. If you're printing, you don't see that it's like, someone prints like the first line is for Kojo, second line is for, no. It takes a page and says, that all belongs to you. Actually, printers are even much more interesting. They take a whole document and say, I'm going to print this person's document from beginning to end without stopping. Even if the light goes off, I'm going to finish So he has this idea that what, once he has a job, he works on it, and then he can pick another one, he works on it. So that means that he doesn't share in that classical sense to say, I have the printer now, let me finish doing what I'm doing. When I finish, then the other process or the other thread can have it and work. Okay, so I'm going to have another one called data. So just a simple class, and in this class, I'm going to make a linked list. Linked list. I hope most of you have at least familiarity with, okay, my class names are very disgusting. Yeah, I tend to write list of, it's always a list of strings, not this list of strings. Right. List of strings, and I'm going to make it public and also include. So sometimes I do like Netbeans. So a project like this, I encourage Netbeans because you'll be coding a lot and it gets annoying having to read up the references over and over. Yes, this should be a new of this one, right? So, sorry. Okay, so this is an object, right? That is available. Right. So within my worker, what if I wanted them to share a linked list? Right. So I'll say public data, right? Currently equals to null, right? But in my constructor, what I can do is, whenever a worker starts, so if two workers, the data type is of type, this class I made, data. So when I start off, I'm going to say data, my data is equal to new data, right? And then I'm going to add to it w-odds dot data is equal to my data. That means that whenever w-odds is working, his idea is that the data is working with is currently called what? My data, right? And then the other one would also say, evens would also say, well, I also think that's the data. Right? So that means that now two people are going to have two sets of data. Right? Now, the other thing I'll do is when they are all working, right? Now, anytime someone prints, we'd like him to add it to a linked list. Right? So the way we do this is, usually we say synchronized, this dot, right? So what this says is, only one person can touch this. Right, that means within this block, so only one thread can be in a synchronized this data. So he can have he can have this section, right? Where is this guy? He too can have this section. But even if the two of them are running, only one guy can be in there. Right. So that means that, so this is usually what we call in operating systems or systems a critical section. That means only one person is allowed to be in there because data is being shared. Right. So for your approach, if you have like your Java code, you have to think of what are the different people. So that means what are different threads who have to run. Right. And then the other thing you have to think of is what is it that they will share. Of course, the easy one I did was what? Just make another class where you keep the data. And anytime someone wants to work with shared data, you say synchronized data, and then he can use it. This dot data dot he had another list of strings. I should have just extended it, right? Instead of doing this. Okay, new string. This should work, right? Okay, can't I make a I dot string, sorry. I think it should be, oh no, he's not an integer class. This is kind of annoying. Trying to think of the easiest, cheapest, I think of the easiest, cheapest way to do this. Okay, so at least you've learned one of my bad habits. Cheap conversion. don't do this all the time, just cheap conversion, like string plus int. At least it works in Java, not in some other languages. Right, so at least, that means that whenever this code is running, because the linked list is now being shared amongst what? Two or more threads. He should make sure that when he's accessing it, he does what? He secures it, he synchronizes, he locks it. And that means that then he's the only person allowed to touch it. Without this, that means that what will happen is someone has maybe increased the size of the linked list. He's going to put it in, oh, someone else comes up and tries to, and so without this, the whole thing will be a mess, right? And in OS, we do much more than this one, but for this class, for simplicity or for survival, I'd say synchronized. Just keep it simple, synchronized. So synchronized is a keyword. So in Java, you have like 4 int. Synchronized means that lock this for me. So for example, if I say synchronized students, that means I lock that student and no other person. So that means for this particular one, so long as I have, so that means almost like every object is a key. If I'm the person holding that key, then only I can work on it, so long as I've called synchronize. So synchronize, I felt the key. And at the end, he's going to let it go. Then someone else can have a go. Right? So you see synchronize as an open and then an end. So at the beginning, he's going to what? Lock the object. And then he can work on it. And then he can let it go. So that's how I use this one. Right? And that means that you can have multiple threads that are running without actually having sort of them interfering with each other. Because if they interfere with each other, what will happen is usually your program will be crashing. And the other thing you saw, because threads, when you saw the output, so that's the other warning, but usually people just hit it a while before they realize like this. It's unpredictable because you can't tell that this will go one and this will go. Even if you say sleep 1 second, sleep 1 second, one day, that day you'll be there, one thread will sleep, the other one will be ready, and the other one will go again, right? So each thread has a mind of its own. Yes, there's some scheduling going on, but don't count on the schedule. That means that you have to be disciplined in terms of, if I know something is shared, I am going to what? Make sure that I synchronize lock it before I do any other action on it. Without synchronized locking, the entire thing would, well, it will run sometimes and it will fail sometimes. And then you'll be wondering, why did it run and why did it fail? Okay. Now the last thing I'll add, well, before sockets, I'm told you have another class. Right. So, the other thing I'll add is, in Netbeans, as in a lot of the IDEs, what you are able to do is you can debug. You can debug your code. And a lot of developers or students are not doing enough debugging, which I think is why some people struggle a lot with projects, because they are not figuring out, how do I debug? So the way you usually debug in Netbeans is you add a line, okay, so like this one, breakpoint. That means that you say, whenever the code gets here, stop. So instead of doing the normal right click and run, I'll say debug. There's an option for debug. So in your line number, you can see the line numbers on the left. You can put these, if you click on the number, you'll put a red dot on it. And if you click it, it can remove it. Debugging. Debugging is very important. Without debugging, this project will be difficult for me, because without being able to stop the code and inspect what's going on, you would not, because something like this should work. You have in your mind that this should work, but it's not running the way it should. That means that you can go to the function and then what? Add a breakpoint somewhere. Right? And now the nice thing about breakpoints is, if you add a breakpoint, you try and tell you all the values in all the variables. He will actually pause for you. So that means that you must have a good strategy for defining variables. So if I'm interested in something, I have a variable for it and I store it. Right? So that when the breakpoint happens, I can see. So once I've added these here, then instead of just right click and run, I'll say what? Right click and debug. It's running. It stopped. Right? And this is what I really like about the debug. So it's telling me that there is this guy who is currently suspended, but he started from, I think he's a main guy, right? And then he has, well, this person who called this. So there's a thread running, right? And if you look carefully at this, right, it stopped on this line. That means that's where he stopped. If you look through here, you'd see usually there's a pause button, there's a play, continue. So if I say continue, that means you go to the next time. So if you keep running until it hits another one. So if maybe there's a sequence of code, you are really frustrated. Some people add breakpoint. So in Java, you keep doing print. You can say breakpoint. And then as it's running, the debug will just say stop at one. And then if I want to go to the next one, maybe I want to find out what happens here. And then here. Let me just move this. So maybe I want to see what happens to the linked list. Right. thread.sleep. Sorry, sometimes these, some of it is interfering with what I want to do. Because I wanted to put it on, but there's also this thing here who's like thread sleep called in the loop. Okay, breakpoint. Okay. If you right click, he'll give you enable the breakpoint or hide the breakpoint. Same thing. Sometimes there are other things on the line number. Okay, so I've added breakpoints. Now if you look at this, this is the data. What I'll do is there is also in your Windows, I know there's debugging. Okay, that's my debugging. Okay, if you go to debugging under your Windows, all the things you see there is variables. Right. Oh, I went away. Right, so I have variables. And if I add and click variables, that means that this is what all the variables currently look like. You can move the, I'm just going to move this down. You can move windows around in Netbeans, of course. Right. And where is the code? This is the code. Oh, which code did it stop at? Was it in the worker? Okay, it stopped in worker. Right. And you can see as far as it's concerned, this is what a snapshot of what the data looks like. So I can see currently it says that what I is 1, J is 1,000. That's the value of this. That's the data. That's the list of children, and that's what's in there right now. Right. So this is, let me see what it's, oh wow, how many things were put into the linked list? Okay, list of strings. Okay, so that means the linked list guy, he's cheating a bit. He's made a bunch of arrays to keep track of his things. Right. So it's kind of uninteresting. So he has a size. I haven't put anything there, but he supposedly has a size. But if I see my int and my j and so on, and okay, that's the boolean. So if I click play, I'm just continue. So he run again until, well, he stopped there at this one. He runs. Okay, he's now here. He runs. He's now at the sleep. Runs. So that means every time he comes, well, watch that every time he comes, the value of the int is changing from 3. I've gone all the way to 5. Kind of clicking very quickly. 7. But he's an odd counter, right? So that means that if you are doing some code and you're trying to figure out why is it not working, you have to what? Add breakpoints, especially if you're using Netbeans and Java. Add breakpoints. If you get tired of it, you can just say, I think some of them have run to the end. Let me see. This has continue. Okay. No, he's starting again. I have to try and find step over, step. Okay, this one doesn't have that option. There are some of the IDs where it says ignore breakpoints and run to the end, where it'll just, right, run to the end. So your option now is, of course, to take your time and then what? Come up with the structure of what are the main things. So at least for between now and Thursday. Right? So think of if a node is there, right? What are the different methods? So forget about the socket craziness. Right? But the first thing is just ask yourself, if a node is there, what are the different things that it has to do? Right? Don't worry about the sockets, but just ask yourself. So that means currently one of your issues is you're supposed to be able to do replication. Right? So replication for something like Hadoop. If you read through the different components, it has a name node, data node. So read through the behavior, and it will give you some hints as to how it behaves. But actually, some of the hints you've already seen in this class. Remember when we're doing callback, for example, there was supposed to be a registry. So that means that the same way that Hadoop has this name node guy and zookeeper who keep track of what are the things, it's a good idea if you have some way to keep track of what all the different things that you need to keep track of. Right? And so that means that for Hadoop, the name node knows all the locations, at least addresses of the people where he's keeping his data. The zookeeper would then know different objects that exist. If you're using HBase, he's keeping track of. Someone has named this object, it's over here. Someone has this table, it's over here. So that means that don't worry about the sockets part. Start with your nodes. So you can pick a node and say, read a question. So each question will say, oh, you're supposed to do replication, and so and so, and it will describe. And that means that you can just pick a piece of paper, start drawing circles, like, oh, this is a node, what does it do? This is another node, what does it do? This is another node, right? And then you just say, okay, what methods do I need? What are the main things I need to do? Right? And for the project especially, it's supposed to work like a mini HBase, but just with what? Key value. So that means that you can actually start writing some of it, because a key value database, you need to have a method to what? Say maybe store, you give it a key and a value, and it's stored. But to convince yourself that it's stored, you also need to have something to check to see if what is stored was correct. So you can have maybe like get, and give it a key, and bring your value, then you are convincing yourself, oh wow, it's working. You can, in the one in each base, you were able to also print the list of the keys and values that are currently stored. Right? I think it was, they called it scan. So you can make methods and say, okay, at least for the key value part, you can use a hash map for that. Right? So that means that you've made your methods, you've tested it, you've convinced yourself. And for usually when I'm doing code, so since this is recorded, I will not be able to just expand, because when I expand, I'm going to take its time and like copy. Let me see, is it? I know there's supposed to be. But you can use a Java hash map. For a class like this, programming 1, if they say make a hash map, they want you to code it yourself. The higher you go, the less we care about settings. But that means that we'd assume that you know how a hash map works. So yes, you can use your linked list, you can use your hash map. If you are concerned about plagiarism, I would say when you go online, you can focus on, I know that people are tempted to go to some websites where they give you blocks of code and you copy paste. But I should warn you that the discussion has been going around that people are copying too much code from offline. And they're actually tools similar to the same way we have Turnitin, where we can submit snippets of code, and we can see that this code comes from maybe Stack Overflow, this code comes from. It doesn't take that much to detect. So usually what we would ask people to do is code from the documentation. Java has documentation, like the labs have documentation. And so if you search online and say maybe Java, Oracle, maybe hash map, usually they would have a tutorial on how to use a hash map. Say Java, Oracle, maybe linked list. They will have, and Oracle has a lot of tutorials going through, so that you don't pick code that is supposedly maybe some part of someone's project. So you can be a little bit, disciplined. The other one I said was you can go to, okay, I think I have some links, and there was one reference in there, right? So read the statement. I've put 1 or 2 more in there. So this just in case you don't sort of go and copy, because sometimes it's kind of tempting to want to say, oh, I want to do socket. But what we did in this class was we at least showed you some references, and just, you can stick to those references, but if you want to expand, make sure that you are within the official documentation. It's just like you're doing a PHP project. If you pick something from the PHP manual, it's less likely to be called plagiarism, unless it says closed book and so on. But when you link, you can say, oh, okay, I got this from this link, right? And you can document it. As opposed to, well, I went to someone's website and he gave me that block of code, and that does all the work for me. And that does all the, but with the way the key value database works, it's very simple, because it will just it maps onto the functionality of a hash map. So you can then add the methods that you can wrap them up nicely. That's like you can say add, get, put. There's just nice wrappers, right? And then that means that the next step is, after you've tested and made sure, okay, even the things like, I know we said we could do things like the parallel computation. Remember there was one we said, well, there has to be able to do parallel computation. Before you do parallel computation, you need to be able to do what? Standalone computation. That means that you can do your hash map and say something like sum, and then see if he's able to do some summation with the data he's got. Or say add, see if you can do some addition with the data. So you can actually do some of these without doing the whole crazy all connected at once. Right. And then next class we'll talk about sockets. But the next thing, if you want to go ahead, so that means a lot of the things that are doing, if you do it in standalone, you can. But for the things that are distributed, so for example, in Hadoop or Java, RMI, he sends information to the registry, it comes back. That means that you have to start planning how messages are sent and received. That means that you say, oh, I need to send information from this one to this one. Then you have to sit down and say, what would the information look like? Or let me pick, okay. So I'm just going to use HTTP as an example. I'm out of time.